Hello everyone. So in this video, I want to talk about solvents. I know it's something that trips up a lot of people, especially when you're learning SN1 and SN2. You're like, wait, what is polar protic? What is aprotic? How do I even identify which one would be a protic or an aprotic? When would I use a polar protic versus an aprotic solvent? And so I wanted to make this video to clear up all of the confusion. So let's begin with polar protic. So for polar protic, know that they can form hydrogen bonds. It tells you in the name, y'all. Protic, proton. I mean, it didn't click for me until now that I already finished Chem 1, and I was like, really? So for protic, think protons. So they can form hydrogen bonds. They can solvate cations and anions. And again, it does affect the efficiency of a nucleophile. And the reason it's going to be better for SN1, as I have on the screen, is because remember in SN1 you're going to form a carbocation, and so when you have this polar protic, again it's going to make hydrogen bonds, so it's going to stabilize the carbocation transition state, which in turn is going to speed up the reaction. So again, if you see a polar protic, it's a really good indicator of SN1. Again, you have to look at the other clues. Again, since polar protic forms hydrogen bonds, if you look and you see an alcohol, okay, that's going to form hydrogen bonds. Remember, phone, FH, NH, OH, all of those form hydrogen bonds. So it makes sense that you're going to have water, ethanol, methanol, tert-butanol, and you're going to have acetic acid. So again, think, is this going to form hydrogen bond? If so, that's going to be a polar protic solvent. Now, for polar aprotic, they cannot form hydrogen bonds, and they can only solvate cations. Notice that in polar protic, you can solvate both. Well, in aprotic, you can only solvate cations. And again, it's not going to affect the efficiency of a nucleophile. So this one does not affect the efficiency. Now, one more thing I want to emphasize. This, with the aprotic, you're usually going to see it in SN2 reactions. And it's not that you can't use a polar protic, it's just that if you use a protic, again, that forms hydrogen bonds, so you're going to slow down the reaction. That's why it prefers polar aprotic in SN2. And think about it. What happens in SN2? You're going to have a concerted reaction. You want that reaction to be short, quick, and to the point. And so it all happens in one step. That's what it means by concerted. And so you don't really want any hydrogen bonds to form. You just want to get in and leave. So again, that's why it would be SN2. Now, for how do you identify? Well, for a protic, we wanted things that form hydrogen bonds. So for aprotic, we're not going to form hydrogen bonds. So really, it makes it simple. You're going to have DMSO, HMPA, THF, DMF, and so on. So again, I hope that this helps you know the difference between polar protic and aprotic and clears up all of your confusions. Again, polar protic, hydrogen bonds, affects efficiency, SN1. Again, you're stabilizing the carbocation. Polar aprotic, you're not forming hydrogen bonds, only cations. Again, it does not affect efficiency. And again, it's going to be SN2 because you just really want a short concerted reaction. You want it to be quick. And so you don't want any hydrogen bonds to mess with it. You just want to do the reaction. Again, to identify, look, is it going to form hydrogen bonds? Yes, that's polar protic. If not, it's going to be aprotic. Again, this content takes time to create, so please follow, share, like, and thanks again for watching.